Solar grade silicon. So I have discussed what are photovoltaic cells. We have discussed the construction and working of PV cells, advantages and limitations. Now let us see how to construct this PV cells or photovoltaic cells. This photovoltaic cells is mainly synthesized using solar grade silicon by unicarbide process. What is a solar grade silicon? So you have two types of silicon. You have metallurgical grade silicon and semiconductor grade silicon. So metallurgical grade silicon contains high quantities of impurities. Therefore, we cannot use it for preparing PV cells. So therefore, we're going to, whereas semiconductor grade silicon also contains impurities but very less. So therefore, we are going to synthesize a silicon which have impurities in between metallurgical grade silicon and solar grade silicon, and that is known as solar grade silicon. We are going to synthesize a silicon which is having impurities lesser than metallurgical grade silicon and greater than semiconductor grade silicon, and that type of silicon is called as solar grade silicon. So let us see what is the process. So it contains two steps. First step is manufacture of metallurgical grade silicon. Second step is conversion of metallurgical grade silicon into solar grade silicon. Step 1, it is manufacturing of metallurgical grade silicon. So we are going to take silica and it is heated in electric arc furnace at 1500 to 2000 degrees Celsius. At this temperature, so what will happen? Quartz will be converted to silicon. So this silicon will be continuously withdrawn from the bottom of the furnace. So quartz will be heated to at very high temperature in electric arc furnace and it will be converted to silicon. So this silicon will be continuously withdrawn from the bottom of the furnace. So whatever silicon is obtained from the bottom of the furnace is subjected to a process called as refining. Thus obtained silicon may contain aluminium or may contain magnesium or may contain calcium. If that silicon contains aluminium, it is removed as alumina, Al2O3. If it contains magnesium, it is removed as magnesium oxide. If it contains calcium, it is removed as calcium oxide. Next, all this is separated and silica obtained is called as metallurgical grade silicon and it is 98% pure. So now our next part is next step is converting metallurgical grade silicon into solar grade silicon. This consists of three steps. The first step is synthesis of silane. So here metallurgical grade silicon which is refined by heating is treated with anhydrous HCl at 300 degrees Celsius to obtain trichlorosilane. Okay, so thus obtained trichlorosilane is hydrogenated further to get tetrachlorosilane. So next we are going to the trichlorosilane is separated by distillation and tetrachlorosilane is converted into trichlorosilane by hydrogenation at 1000 degree Celsius. Thus obtained trichlorosilane is passed through a fixed bed of columns containing quaternary ammonium or ion exchange resin catalyst where silane is obtained step by step. That is, trichlorosilane is converted into dichlorosilane and thus obtained dichlorosilane is further hydrogenated to get silane. Silane is nothing but SiH4. Okay. So now the next step is purification. So purification is very important. So how is this silane purified? The silane is purified by a process known as pyrolysis. What is pyrolysis? So thus pyrolysis is a process where we are going to heat the silicon to very high temperature. So a process where you're going to heat a compound to very high temperature, and at that temperature if the bonds break, it is called as pyrolysis. So here we will take the silane and heat in a reactor to very high temperature. When you heat it to very high temperature, silane decomposes to give silicon and hydrogen, and that obtained silane or silicon is called as solar grade silicon. And the solar grade silicon looks like that as it is shown in the picture. So that solar grade silicon can be further purified by zone refining technique. So this solar grade silicon, as I have discussed, it is used for manufacturing PV cells. Okay. So in the PV cells, the main disadvantage of the PV cell is, so whatever it produces only DC current, and in cloudy days proposed amount of current cannot be obtained. So because solar cells mainly depend upon sunlight, so during cloudy days what happens, the sunlight will be very diffuse, right? So the proposed amount of or the expected output will decrease, okay, during cloudy days, and it is practical only in areas with favorable climate. That is, in tropical regions it is good, whereas in Bangalore nowadays it is changed, but earlier in Bangalore only during summer you can use these PV cells. In winter and rainy seasons you cannot use this PV cells. So these are the main, and other thing is installation cost. So installation cost also is very high. So why is this installation cost is high? Why I am talking about the limitation here is, so those things we cannot do because it depends completely on sun, right? So sunlight is diffuse, those things we cannot do. Other main disadvantage is installation cost, and PV cells are also very costly. So since PV cells are costly, the common man cannot buy the PV cells. So why is PV cells are costly? Because this process. In this process, what we're going to do, we're converting the metallurgical grade silicon into semiconductor grade silicon. So the conversion process is less. Even though the quartz is available abundantly, the silicon is not converted. We are not getting sufficient quantity of silicon. We are not getting abundant we are not getting the silicon is abundantly available. That silicon should be converted into solar grade silicon. This process is costly. Whatever process we have discussed now, indium carbide process, this process is costly. To get solar grade silicon, it is very costly. If this process is minimized, then PV cells also will be cheap, and even common man also can be used, as earlier they used to use here television antenna. As television antenna used to be in each and every house, even the solar grade PV cells can also be used. Now we are using solar water heaters, right? Similarly, each and every house can be roof integrated solar system. So if PV cells are cheap, then that also be. So now R&D is going on to minimize the cost of the PV cells. So once that is done, then it can be used by common man. So thank you all.